Okay, can you see the slide? Okay, we are talking about access control rules. Okay, you can see the slides hopefully. Access control list. What is ACL actually? It is just filtering traffic. In the last sessions, we discussed about routing. Okay, when we configure routing on routers, then whole IP block or whole network is reachable from one router to another. Okay. But on top of that, if you want to allow or disallow a specific IP address, for example, in this slide, you can see that 172.16.0.0 network, okay, or 172.17.0.0 subnet mask is missing, however. So when we give routing, whether it is static routing or it is dynamic routing, these routes are available to the whole block. Okay, say in a network you have 100 computers, and another network you have 50 computers or servers. All of them are reachable from each other. Okay, and this is open for all the devices if routing works. So access control list works on top of routing. We just want to control a specific IP address or range of IP address. Even whole subnet can be blocked, can be allowed in some region. Sometimes you allow a specific IP based on source address or destination address. But another factor that works in extended ACL, where you allow or disallow a specific service. Say you want to block FTP service, everything will be allowed, but you want to say that we have two computers that should not be allowed FTP service, okay, or some other service. You know that every service has have a different port, okay, layer 4 port, UDP or TCP port. We will allow or disallow based on source and destination and port. We will show. Okay, so why ACL is used? IP traffic by filtering packets passing through a router. Okay, identify traffic for a special handling for two reasons. You heard about firewall. Firewall is used to protect network by allowing only required traffic for your organization or system, and disallow or deny traffic. So this can be performed also in router, but it is limited. Router, every router has some firewall capability that is only packet filtering. That is called packet filtering firewall. But what we talk about next generation firewall or firewall, that is very advanced, have many advanced features. They can filter traffic based on many different factors. But in router, we use ACL. ACLs are also used in firewall, which is different device or appliance. Of course, firewall has some routing capabilities also. But we are talking about ACL only in router. Okay. How traffic is filtered? Say in this network, a small diagram, router, and then we have a computer. Okay. Virtual terminal line. Okay. So in ingress, okay, you have to understand two types of traffic. One is inbound traffic and outbound traffic. If traffic is entering to a router, then it is called inbound. And when when traffic goes out of router, then we call outbound. Another language used is ingress and egress. Ingress means inbound, egress means outbound. Or in or out. Okay, in is the term in and out. So what we do with ACL, we just permit or deny packets moving through the router. Okay, permit or deny VTY access to and from the router. Sometimes we want to restrict. Say an important example. Say you are working in an organization. You are working in IT department, and it's a big organization. So IT department is only responsible for maintaining routers. Other departments has nothing to do with routers or other systems. Okay. In that case, you will allow if the router access this, that only IT people are allowed to log in for management, SSH or Telnet. Okay. Others will be blocked. So chances are that in your organization, if people working in other departments may know, may have IT knowledge, or they, in fact, they are hacker, for example, and they want to log into a router and damage, which is called insider threat. Okay. An inside employee can cause or harm system also. So to protect this, you only allow the IP address block that are used by IT team. You can even control in more granular level if you have different IP blocks in IT team. So those people who are responsible for administration of routers, switches, and other network devices, that IP block will be only allowed. Other support team in the IT or junior who are not involved in this can be excluded. Okay, so this is practical scenario. So what would happen if you don't have ACLs or access control list? All packets could be transmitted to all parts of your network. So if there is no control, every packet will be transmitted as per routing, static or dynamic routing. Okay. Okay, let's look at another application classification. Okay, in a router we can allow this. Say this is a router. At one side of the router, EIGRP is working, on the other side OSPF is running. So if we want to exchange routing information between them, we have to allow, or sometimes we have to block. Say we don't want to OSPF related update through the router, then we will block the port that is used for OSPF. Okay. This is an algorithm. You can see how packets are filtered. When inbound packets are received, what happens? Okay. At first, routing table entry is checked. Okay. If routing table entry is found, if there is no routing, so ACL has nothing to do, because traffic is not allowed in that. Okay. If routing table entry is there, then ACL will take effect, and ACL will discard or allow based on ACL statement. Okay, this is more or less the same. There are different types of ACL. Okay, standard ACL, extended ACL. The standard ACL checks only source IP address. Generally permits or denies enter protocol. Okay, if you want to allow a IP to a server or to a router, then you use only source IP address to block it. Okay, that is very simple. Say you want someone's computer should not be reachable, should not reach a specific server. So you just deny this IP address and write in a statement in the router, and it will be blocked. But it is very simple. Then we have extended ACL. Extended ACL is more rich. It is richer actually. It can check source and destination address. Okay, and protocol. Say you want some specific IP address or address range should not go to other specific IP or IP address range, and you can mention, and you can mention, you can also specify level 4, layer 4 protocol, that is port, TCP or UDP port. Say you can say you want to disallow or deny FTP, say, then FTP is 421, you will block 21. If you want to block HTTP, so you will block 84. And another two issues: standard numbered ACL and named ACL. There are other two issues. That is, there are 4 types if we only consider standard ACL and extended ACL. Number means we will use the number. Sorry, you use a number to identify a specific ACL statement, or we can use give a name as you wish. Okay, based on your specific service or your purpose. Okay, we will. So just remember, numbered ACL, we have 1 to 99. You can use it arbitrarily, no problem. But you have many ACL, then you have used carefully. And then 1300 to 1999. Okay. And extended number is 100 to 199, then 2000 to 2699. Okay. And or name, ACL has some name, use some name. Okay, we will do some lab, then you will be clearer. Okay. Okay, there are some formats. Actually, we can show it. So here in the example, Telnet to connect to a router and authenticate. Okay. We can allow FTP, HTTP, and so on. So reflexive ACLs used to allow outbound traffic and limit inbound traffic. There are time-based ACL. Okay, sometimes you will use time-bound, although we will not go in details about this type of ACL. Time-based ACL means when you want to allow a specific service for a specific time. So you have a banking server, for example. Okay, you are working at a bank. You know that say in Bangladesh, banking period is 10 to 4 p.m. for example. Financial transaction occurs by human tellers. Okay, who sits in the front end of a bank. Okay. So those they gives input in the servers, some servers for this type of transaction. So after 4 p.m., you will just block all the computers of those tellers desk. Okay, just block to the server, so that no one can give input to the server. So it will be more, it will be safer for the system. Okay. So it is very important for sensitive system or organization. So time-based ACL can be used also. It is very interesting. And here we talked about wildcard mask when we configured dynamic routing of OSPF and EHZ. We used wildcard mask. In ACL, we also use wildcard mask. How to convert wildcard mask, you would know. However, I also included here. Okay. Then what is the syntax of this type of ACL? Let me show you in, briefly before moving to our lab. Okay. Access list number. You will give a number. Okay. Then whether you permit or deny or remark, you can also put remark. Remark means you make some description or comment, so that you later you can understand why you configured this ACL, or otherwise you will forget, and you yourself will be confused. In real life, you have thousands of ACLs in a router. Okay, although in our lab we will just test for 1 or 2 statements, or 4 or 5 maximum. Okay, IP access list, access number. For example, here is an example. What is happening here? Access list 1. Okay, at first you will write access list, and then 1. 1 means 1 to 99, any number you can write here from 1 to 99 range or other range also, which is mentioned. Okay, then what you want to do? You want to permit, okay? And then you write this statement. And then wildcard mask. Because it is the mask is 255.255.0.0. Just regard. Implicit denial, not visible in the list. Okay, when we write access list, then there will be implicit deny. Implicit deny means if it is not allowed explicitly, then it is denied. It is firewall's rule. In that case, everything, any other thing will be denied. So then, when you write the statement, you have to apply it to a specific interface. Say here is two interface, three interface, Ethernet 0, Ethernet 1, and serial port 0. So where we are going to interface to apply Ethernet 0. Okay. What we are doing here? Here we have a computer in 172.16.3.0 network. Okay. In this network, we have a computer. What we are trying to do, we just try to allow 172.16.0.0 network to this. Okay. Then what I write, IP access list group 1. Group 1 means number of accesses. If you wrote it is 72, for example, if you write access list 72, then you have to mention here 72. You have to mention it 72 out. Out means outbound. That means traffic will not go out towards the computers. Okay. And we also applied the same ACL to other interface to E1. Okay. Okay. Do you have any question?
Yes, sir. Just this last statement. Can you please elaborate a little bit on them? Where we're having this IP access group 1 out.
Yeah, 1 out. Out means okay. Look, here we are seeing three networks. Okay, one is 172.16.0.0. It is coming through serial interface to this router. Okay. For some reason, maybe say everything is blocked in this router. Every network will not be allowed. Now we want to just allow this network. Where we allow, we are allowing to the E1, E0 interface, Ethernet 0 interface, Ethernet 1 and interface. Through this interface, we are just allowing or applying our access control list 1, which permits the network. Okay. At first, we define whether we permit or deny. In the access list 1 permit 172.16.0.0, then wildcard mask 0.0.255.255. With this, we just permitted. But with this statement, it is not sufficient to control traffic. Traffic will only be controlled when you apply it to a specific port, router's port. Okay, here are other two ports, Ethernet 0, Ethernet 1. Okay, We are just applying this rule. We call it by name, access group. Although you will see a difference. Access list 1 is defined, but when we apply in Ethernet interface 0, Ethernet 1, we wrote IP access group. Okay, IP access group 1. Actually, access group or access list are referring to same access list. Okay, somehow Cisco use different language. Who knows why they are using different keywords. Okay, but we have to remember it. Then we applied IP access group 1, that is access list 1 in outbound. Outbound means from router's point of view, not computer's point of view. Okay, that means this route is somehow in this router, and this is allowed to Ethernet 0 and Ethernet 1, and it is outbound, that is it is out. Okay, now clear?
Clear, sir.
Okay, great. Then we have another statement. What? Oh, here. Okay, you can write more than one. You can write more than one statement in the same access. Okay, they will work sequentially. At first, access list 1 deny. There is a you can see on the right hand side 172.16.4.13 is the computer. Okay, and it's a specific for a specific host. You know that subnet mask is 255.255.255. That means 4 or 255. Okay. So what will be the wildcard mask? Just 0.0. Okay. So in access list, we want to deny this computer, which is 4.30. Okay, and we will permit others. Okay, 0.0.0 means all others. Okay. And how we where we apply this Ethernet 0 point? We want to apply this for 170.16.3.0 network. Okay, which is connected to Ethernet 0 of the router. So if we apply this access list IP access group 1 outbound, then traffic will not. Traffic will be allowed according to access list 1. What is access list 1? Access list 1 will deny or block 4.13 IP and allow all other IP addresses. Okay. And what is number? Okay, well, we can write in different ways. Okay. Like here we at first we denied a network 172.16.4.0 and then wildcard mask. It is denied. Okay, and then we will allow or permit any. Any means any keyword is used to mean any, everything. Okay, so when we run this access list, it will work sequentially. At first it will deny. Okay, then any will work. Imagine if you write one permit any first. If you write this statement first, then deny, what will happen? No traffic will be denied, because at first permit any means everything will be permitted first. Okay. So sequence is very important here, and here also we applied Ethernet 0 and we use IP access group 1. And then we have also this same thing, or more or less. You can go through all this. And then another way of defining this is similar. Why? Is there anything wrong? A numbered will show extended. Okay, extended ACL are actually a longer statement. In the previous slide, you can see all the syntax rule. Okay, I am just giving you example and describing it. That will be easier for you. Look at this. Here we will use extended list. When we will extended list, when you you will mention a specific port. That means layer 4 or protocol will be used in access list. Then you need extended ACL. In that case, standard ACL will not sufficient. You need to use extended ACL, and extended ACL's number will be from 100. Okay, here we use 101. So what is our aim in this statement? We just try to deny. We want to telnet. We want to deny telnet. Okay, last sessions we discussed telnet is not secure. Sometimes we will not allow it. Okay, imagine we will not allow telnet. So telnet's port is 23. So from where we don't want to deny. At first, look at the statement as access control, access list 101, and then deny. You will deny. Then you mention TCP. You know that Telnet is TCP protocol. Then you mention the IP address, source address. Okay, source address 172.16.4.0, and then wildcard map. And this network will not be able to access TCP. TCPs and it is Telnet. Telnet will not be allowed. Okay, any means destination. So they cannot try any Telnet from this network. 172.16.4.0 network will not be allowed to use any Telnet. Okay, to hire any means anywhere. Okay, or we can specify. In some statement, we just specify a specific IP address where it should not go with Telnet. Okay, EQ means equal. Equal, it is syntax equal 23. 23 port will not be allowed with this source and destination. And last statement is access list 101 permit IP any. IP protocol will source any and destination any. And next, this next statement is used to allow all other traffic. Okay, if you use only first statement, then all traffic will be denied by default. That is why you mentioned that all other traffic are allowed. Now, a similar way, just we IP access group 101 outbound. We applied outbound of the router. Okay. Okay. Is it clear to you, or have any question? Abdullah? Can you hear? Ali Atik, Atiku. Marjia Khatun. Marjia. Okay.
Yes, sir. Sure, no.
Can you understand this extended ACL statement?
Yes, sir.
Okay, good. Any other? Abdullah is are you present, or what about Mdikko? Yeah. Can you understand the statement of extended ACL?
Yes, sir.
Okay. Okay. I mentioned all the statements, syntax. You will go through this slide I will provide. Now we'll practice a lab in router. So look at the standard numbered ACL here. So we have 4 labs regarding SCL. We are using any router. Okay, we are taking this. Okay, let's go to the lab scenario. What we are going to configure, applying standard numbered ACL. We have 2 types of ACL in terms of referring how in the interface. One is number, one is name. Okay. So lab scenarios, we have 2 routers, and in router 3 we have some networks. For simplicity, we use just loopback. We can use a big network diagram, but that is time consuming. To use just 2 routers, and for a specific network we use loopback inside the router, and we can apply some configuration testing. Okay. At first I'm showing you, remaining you will practice. Here in the lab scenario we use serial port, but in practice let's try with just Ethernet connectivity. Actually serial connection is rare nowadays, and I never use in real field because it's not used nowadays. It is legacy technology. In old days it was used. Now we get Ethernet. We have just fiber connection, and then we use different Ethernet connectivity. Okay. Okay. So here one is router 1, and then other is router 3. Let's configure. So in router 3 we have, what is interface in the configuration? Okay. But okay, basic configuration is missing here because basic configuration is already known to you. Okay. Okay, we have one interface with other 00 is connected to other router. At first, we have to configure point-to-point IP, point-to-point IP. Here, what is point-to-point IP? It's 172.16.1.2. But here is /26. It should be /30 actually. Okay. Why they use it? Okay, we can change it. Okay. Okay, we can do it ourselves. Connect interface gigabit Ethernet 0/0. We are giving what IP is IP address. What was the IP? 172.1.1 or 16 is missing. 16. Subnet mask will be 255.255.255. Say 252. Okay. And then we configure all the loopbacks. We can copy from here for saving our time. Look at this. Copy this in the notepad. Okay, host name, we can also configure host name R3, for example. Okay. Then loopback. Okay, we have some networks as per our network diagram. Okay, we have 10.10.10.3 /25 and other 2 networks. Okay, we have 3 networks. Yeah, 0 to 0 should be what is it? No.
Sir,
Yeah, yes.
sir, I'm there between the names of absent and present, sir.
For today.
Yeah.
Just inform our training coordinator, Mr. Moshin. Okay. In possibility here. Okay. Give him a message, or if you have any contact number or his WhatsApp, then give him input. Okay.
Okay, thank you, sir.
Okay. Let's look at this. We are creating loopback and the router. Let's host name say R3. Okay. And then we are doing this. Okay, we created the loopback network. And we will also give, we are giving also a static route. You can also dynamic route. Okay, let's see. So I think, okay, we are getting 3 loopback network or interface, and we have created our point-to-point interface also, which is down because we have to enable on the other side. Okay, go to the another router. It is router 1. R1. So here we have IP as interface gigabit 0/0/0. IP address should be 172.16.1.2. Okay. 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 No, it is down because we have to. It's not sure. No sure. What about other sides? I see. Is down. We have to configure. Now, link is up. Then here we also should give the routing. So it is IP route, static route. You can configure. Okay. We can,
Destination IP address.
yeah, destination network. Destination means say okay, we can use three networks. Okay, what are they? These are, okay, 10.10. Okay, and let me tell this. Okay, but we have to edit it. Okay, prepare first prepare the command. Okay, IP route. At first we have to define the destination. Destination is this. What is this? 0.
And exit interface for nest hop.
Okay.
Exit interface for nest hop.
Yeah, exit in no, at first we have to give IP network, then
then
subnet mask.
and then
Subnet mask is like this. Then we have to exit interface. What is exit is GI. Exit interface is GI. Okay, okay, exit. Okay, great. And then we have to get this. Okay, write down, just copy, put two more times. Always prepare the commands in your notepad, and then go to okay. Then we have okay. It is 20. Okay. So it is 20. Right, okay. It is what is 240? Okay, it is subnet mask is different quite. 240. Okay. And we have 30 also. And this, what is subnet? 248. 248. 248. Okay. Let's copy them and execute in the router 1. It is router. Oh, there is some meaning. Okay, let's change. It is actually 3. It is actually 1. Okay, we will execute here. So just I copied all the rows. Let's see what is that. So IP route. Can you see we have 3 static routes defined? Okay. We have connected route. We have what about router 3? Let's show IP route. Okay. From router 1. Okay, let's ping. Which IP interface? We define 3 loopback. So this IP 10.3. Is it pingable? Let's see. Yeah, what is happening? Yes, we can ping. Okay, we can ping. What about 10.2020? That first packet is actually lost. That is dot comes. Okay. But when if you try again, then you will get all the 5 packets are okay. Okay, exclamation sign. Notice it. Okay, what about the 30 network? Sorry. That first packet takes time, then look. Okay, done. That means what I showed up to now is that we created 3 here. We created 3 networks using loopback for simplicity. We could use switcher and then PC. Okay, you can also do in that way. Okay, but using loopback is simple way. Just creating networks in the inside the router, and you are experimenting with this network. Okay. Up to now, what we created a point-to-point interface and then routing between 2 routers so that they can reach each other, and created 3 loopback network and loopback interface. And we tested from R1 that all those loopback interfaces are reachable. Okay, why reachable? Because we use static route. From R1 we use static route, from R3 we use default route. Okay. Okay, you can use default route from both end also. Static route from both end, no problem. I use it. Okay. And now we are going to test, which is our aim in today's lab, to check access control list. How we can create access control list and how we can apply and verify. Okay. To control traffic, just to control. At first, we are using a standard ACL. A standard ACL are simpler and it is numbered. We use numbers to identify ACL. Okay. Let's go to that part. In task 3, we just ping all this interface and found that all are pingable, all are reachable. Okay. Now we are in task 4. Look, what are our ACL? We give the ACL number 10. Okay, you can use 10 because it is 1 to 99. Okay. And then you can add remark. Okay, remark. Why use? If you do not use remark, it is not a problem. It will work. But what will happen if you are using thousands of ACLs in your router? Maybe you have other colleagues in network administration team who are also creating ACLs in the router. So how can you know how others are creating, why others are creating ACLs, or why you are creating ACLs? Nobody will understand. Okay. So for this reason, we will create a remark. Okay. I found that in some organization where I work, some people create just ACL. When I tried to work, I was confused why they are using this service, permitting or denying. So if you mention clearly in the remark, then it will be easier for everybody. Okay. So what are the aim of this ACL 10? What we are going to do? We are going to permit loopback 10 network in router 1. Okay. And we are going to deny loopback 20. We have here we have the 3 loopback. Okay, loopback 10, loopback 20, loopback 30. Okay. What we are trying to do? We are trying to deny loopback 20 on. Okay, and just we will allow 10 and 30. And we will use it inbound. Okay, inbound means, look at the stick at this router 1 has interface gigabit Ethernet 0/0/0 connected to router 3. So what we are trying to do? We are trying to block a loopback 20 network in the gigabit 0/0/0. That is, we want to control traffic inbound. Okay, we don't want to enter this traffic in router 1's interface. Okay, we will enforce or apply ACL in that port. This is our task. And now we find that all the three networks are reachable, but we will just block them. How we block them? Look. So we will configure in this router one. We will take the let's copy the commands. Show you how we use the at first here. Okay, for remark, we permit from R3 loop vector. We are permitting it. Okay. So we are writing in this way, but we can simplify this statement. We will do that with just two statements also. But at first, do it in this way. But interface is gigabit GI 0/0. Okay. And how we apply it? IP access group 10 inbound. Then we'll end our command, and how we can check that our ACL list is there. Let's look at this. Go to the router one and run this show IP access list. There is no access list, okay? Because we have not defined. Now we will create. So look, what about other one remark is missing here. Okay.
Yes, sir. You delete one comment.
Yeah, one comment is missing. Let's edit. It is permit. No, it is permit. Permit. Allow from R3 loop back 20. It is 20, not 20. Start. Okay. What we are doing, we will permit loop back 10. We will permit loop back 30, and we at first the statement syntax is at first ACL, then number, then permit or deny, then source address, then wildcard mask. Okay. 120 255.255.255.128 was our mask, and reverse is 127, and others are 0. Okay, let's define. Go in router. Okay, one also copied. What is invalid?
Last command. Last
one.
one.
Yeah, 1A. 1A. Local. Okay. Okay. We have to be very careful about. Somehow there is one extra A. Is it in this also? No. Somehow I copy some. There is miss. What was why it happened? I still missed why it happened. Okay. Now all the access lists are available. Okay. Let's wait. And now see show IP access list. Okay. Oh, sorry. Oh, sorry. So IP access list. Okay. And look, it is one access list with 3 statements. Okay. Here see. So we have what we are doing. Access list has 3 statements, 10, 20, and 30. Okay. We have permit, we have deny, we have permit. Okay. So if still it will not effective in router 1. When it will be effective? When we apply in the specific loop. We are applying it, or just write, then in router 1, T, okay. Yes. So we will enforce this ACL in gigabit Ethernet 004. Okay. In what direction? Inbound. Actually, we don't want to get traffic in our router. So we will deny it inbound. That means once someone unwanted comes to our door, we will just deny inbound. Okay. Or when we want, someone cannot leave a place, then we will use outbound rule. So in jail, it is outbound rule. Okay. So no prisoner can escape. Okay. So it is outbound. They have this is outbound rule. So someone cannot enter a building and door is closed. It is inbound rule. Okay. Just remember it. Simple way. Okay. What is syntax? IP access group. Okay. IP access group, then tab, it will auto complete, and then you list name. Okay, we created access list, standard access list 10, and in which direction? Okay, it is actually a restricted building. So we don't want to allow unwanted people. Okay, so it is inbound. Okay, and then now check our 3 ping test. Okay, ping 10.10.10.3. Okay, it is pingable because we allowed it. Go to 20. Okay, it's not pingable because our policy is working. Oh no, sorry, mistake. Okay, it will not be pingable. Okay, then what about 30? Should it pingable or not? Okay, it is pingable. Okay, ping. Okay, your traffic is blocked.
So how is it working like that? Because we said that it is inbound, that is the traffic coming from outside to gigabit 0/0/0.
Yeah.
But why here it is outgoing? We are pinging outside, but we cannot ping. How is it working like that? Or if you apply ACL, it apply to both inbound and outbound.
No, it is we applied inbound.
But from router 1,
Yeah,
from router 1 to router 2.
let's look at this which one? Packet tracer. Okay, packet tracer. We have 3 networks in router 3, but we are applying our ACL in router 1. So we want to block one network out of 3 in the inbound interface. That is, we don't want we just want to deny one network in gigabit 0/0/0. We are in router 1, and we allowed other 2. Okay. But in this lab, it is written as three statements, but we could use two statements in this way. Look, just we write this one. Okay. It would be better. Okay, we just write this command. Okay, and then allow all. Okay, we can write another. That would be like this, and this is permit. Permit. That would be permit any. Okay, you will get the same result. Because actually in this network, we just allow any network. But allowing a specific network is good practice. Okay. Allowing in this, we use three statements for permitting two network and denying one network. We use three. We specifically mentioned. But when we permit any, that means any other network can be allowed. Okay, can you understand the differences between two approaches? It is very important because one has security issue. Say there are two approaches: whitelisting and blacklisting. Whitelisting means only a specific persons are allowed. Say you are in a restricted building or office where only a specific person, say 5 persons are allowed in this building. Okay, it is whitelist. What is blacklisting? There are 7 unwanted people. Okay, we have a list. These 7 people should not be allowed in this building. They are in blacklist. But here is risk. Risk means the security will disallow only these 7 persons. But what if another dangerous person like that's one of that 7 guy come and he or she will be allowed? Okay, that is the risk of blacklisting. So whitelisting, we use this whitelisting in the first whitelist and blacklist combination in a sense as denying. So whitelist means you allow, blacklist means you disallow. So two approaches, however, try to understand in a simple way. In this way, we just specified a specific network. In this network, we just denied a network and allowed other. There will be same result. Okay, with just 2 statements, here we use 3 statements. Okay, it is ACL. It is very simple, but I should show you extended ACL also. Extended ACL is quite tougher, I would say, because there are other things to consider, and there are 4 labs. Okay, you will do it yourself, but I am showing you an extended ACL. Okay, what is this? Like named ACL, numbered ACL. Okay, another way I am just showing. I will not show in the packet tracer. It is numbered. Okay, I will share with you. Okay, no problem. What about named? What is the named SCL? Okay. Named SCL and
So,
numbered
sir,
SCL. Yes.
yes, can you open the packet tracer, your packet tracer file?
Yeah. Okay.
So here we have seen that all the network is created on the router 3, right?
Yes.
And then we try to ping from router 1 to router
Yeah.
3, the loopback address. So
Yeah.
is it that the thing has been successful, but we are unable to receive the ping request since ping is free, requests are applied. So we are unable to receive the reply from the loopback address since the traffic is blocked. Is it like that? Because you define the inbound. You define the inbound. That means traffic coming from router 3 into the
Yes.
router 1.
Yeah.
Or the request has been reached, but we are unable to receive the reply, right?
Yeah.
Oh.
Another approach actually depends on your scenario where we create ACL. You can also create ACL in router 3. In that case, what you do? You will create outbound ACL. Okay. You will get same result. Okay. You create the ACL. Okay, but in that case, you have to create extended ACL. In that case, you create with a standard ACL also possible. You just create 3 ACLs and apply outbound. That means I will not allow traffic to go outside.
Yes.
Okay, that is also possible. Actually, it depends on your scenario, what you are trying to do. Okay, you have flexibility. You have inbound. Actually, actually sometimes you have control on your traffic, or sometimes you don't have control on it. For example, if you have connected to ISP router, on ISP router you have no control. Do you have any control on ISP router?
No.
No. In that case, what will you do? You will implement inbound rule. Okay. So I don't want to enter this type of traffic to my network. Okay. I will create inbound rule. When we will create outbound, say there are some sensitive server in our organization. We want to ensure that in no way traffic cannot go to the ISP or other network. Okay, that will be a problem. So what we'll do? We will create outbound rule so that outbound network, outbound traffic cannot go from my network or router. Okay, this is the issue.
Yes, sir.
So just understand all the concepts, how we do it, or another consideration. Sometimes we have to create rules to the nearest to the source. Source traffic should be blocked. Okay. Why we should block traffic nearest to the source if possible? Because if traffic goes out of the source, it can be misused or accessed by unwanted user. Okay, but it is not always possible. For example, if you have a server connected to router 3, okay, and you have another router connected to router 3, and so another 2 routers, including router 1. Imagine, let's say like this, just a draw, just to, in that case, you will imagine easily. Look. Okay. Say we have a server. Okay. This server. Okay, this server. if you so you want that this person like this here another person say, look at this. This is server, and then we have a PC, and we have also users and routers too. Okay, 1941 router. If we block traffic inbound, say in the interface of the server, then traffic will not be able to go anywhere. Say anyone, any PC connected here, if say any legitimate user, PC1 say, PC1 is a legitimate user, and he will not be able to access this server. So what we will do, we will create outbound rule if we don't want to reach this server from PC01. Okay, or we can also include configure inbound, but we will prefer outbound because it is nearest to the server. Otherwise, traffic will traverse unnecessary path. Okay, someone tried to ask question, maybe Abdullah. Okay, okay, ask question. You try to ask something. Okay. Okay, it is clear. Is it clear to you?
Yes, sir, it's clear.
Okay.
Thank you.
Yes, sir.
Okay, we'll go. Okay. Okay. Next, go to extended. Okay. Before going to extended, let's just give you a brief introduction to named SCL. Named SCL means named SCL and standard SCL, numbered SCL are same, but they use different approach in case of, in referring. Referring means how do you refer your SCL. In standard SCL, you use a number. So, IP access list. Say in previous lab we use 10. 10 means to refer the standard SCL. But in named SCL we use a name. Okay, we use the name. IP access list, then standard, then you give a name. Okay, whatever you like, and name should be understandable to others. Okay. Can you hear me? I was disconnected. Maybe network was interrupted. Can you hear?
Yes, sir. Yes, sir.
Yeah. Okay. How is the whole screen sharing? Okay. Now I cannot share the. এই কোথায় তুমি? ওই ইয়ে হচ্ছে দেখো তো ওই যে নেটওয়ার্ক মানে রাউটারে মানে চাপ টাপ পড়ছে কিনা, এখন পাওয়ার আছে কিনা। আচ্ছা ঠিক আছে এখন ঠিক আছে ওকে নাও give the permission. Interruption is very disturbing. Okay. হ্যাঁ মহসিন ভাই ওই এটা করে আমার হোস্টটা চলে গেছে আর কি কোনো কারণে ওই যে ডিসকানেক্ট হয়েছিল তো নেটওয়ার্ক ডিস্টার্ব হয়েছিল না 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 অন্য কেউ হোস্ট নিতে মনে হয় দেখেন আর ডিফল্ট হয়ে গেছে আর কি হ্যাঁ দেখেন ওকে Okay, most of the participants recommend 9 to 11 or 9:30 to 11:30. So I think okay, 9:30 to 11:30 will be good for Friday. Okay, some participants also recommended afternoon. But most recommend in morning. Okay, we will continue morning around 9:30. Okay, okay. See, we have to mention access list 10 permit. Okay. But in this, just we write remark and deny a permit also easily. This is the difference, and all the concepts are same. But named STL has another advantage because if we want to create several statements, then it will be easier because IP access list keywords don't need to be repeated. Okay, you just try it yourself. Okay, it is same concept. Okay, we will. I am just trying to show you an extended SQL. Okay. How it is done. Extended SQL restricting inbound telnet access using extended ACL. So we can use same topology. So in IP, in this topologies, configuration, basic configuration are same, but we will work with Telnet, the line between your virtual terminal and the router 1. In router 2 system configuration, what we are trying to do. Okay, let's configure SSH first in both routers. Okay, line BTY, you know, the command. Okay, you know. So delete Okay, for you. You know the command regarding this. Then we, okay. How we'll do the line? Line BTY 04 and router 1. Okay. Line BTY password. Password. What is password? Cisco. Let's login. Okay. And same command here also. Line BTY 04 password. What is password? Cisco set. Login. Okay. And okay, let's try to telnet. What is the IP address of this interface? 172.16.1.2. So we have to allow telnet maybe. Okay. Telnet is not okay. To specify telnet. What is the command for telnet? Okay, line BTY 04, then line O, the one command is missing. Okay, that is transport. What is the command? Forget. Okay, let's see.
Transport input.
Yeah, transport input.
Telnet.
Telnet. Okay.
Yes, sir.
Where we did it here. Okay. Where we is transport input then telnet. Okay. Okay. For anything we can do this. Yeah. Okay. Here somehow miss. Is put telnet. This is also missing. Yeah. Router 1. Okay. Let's do it in the router. First router 1. So let's line BTY 04 transport input. So
Okay, stop.
transport input. Okay, telnet. Okay. Let's see. Let's see the show run whether all the okay password and telnet. Okay. Okay. In router 3, we have to configure the same thing. Line BTY 04. Okay, transport. Okay. Now we should messages other router, or from R1 we should telnet R3. Just how to check from one router to another router, you can telnet or SHH. Okay, it is just use this command say 1.2. Okay. It's not working. What's wrong? Okay, let's check from here. Telnet 172. What? Oh, let's be sure what is the IP address. So it is 2. So one should be Telnet 172.1.6.1. Okay, somehow a telnet is not working. Oh, we need a username also. Okay. Oh, without credential. Okay. Or we have to create okay, what we did last day, we created if SSS, we have to create a username password. Okay. Say with this. Okay. This is mistake. Okay. So yeah, one have three. Admin Cisco. And now Telnet. Telnet 172.1.2. Telnet is not okay. Somehow Telnet is not functional. Okay, let's ping 172.16.1.1 and is pingable. And what about other? Okay, somehow, okay. What happened? Okay, traffic is blocked for some reason. That is why you see okay. Okay, ACL is doing something wrong. Okay. Okay, ACL is disturbing from here. Look.
Maybe implicit deny all.
Yeah, you are right. Yeah. What we are trying to do with 172.16.1.0 network. Okay. But this network is not allowed in the network. Okay. Okay. At first, what we try to we need to remove all the ACL statements. Okay. We have to remove statements.
Or you can allow any in.
No, actually, this lab is focusing on extended. Okay, so we should remove all the standard STL commands. Okay, what was our standard? Look at this. Okay. No. Control A. So we should remove this in router 1. Okay, when we ping a host, then we will get dot 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 means this is not reachable. And when we get exclamation sign, 5 exclamations, that means 5 packets are successful. It is ping successful. Okay. In case of ACL is blocking that traffic, you will get UUU. Okay. Capital U. Okay. Now we just know what if we did it done. Okay. So run. Is there ACL? Let's show IP access list. Access list, no. Okay, now it should work. Because no SCL is now okay. Telnet 172 16.1.1. Okay, now password from came. Okay. Okay. Look, from R1 we entered R3. Okay. We can exit. Look. Okay. Now what we are trying to do? What we now close. Okay. Now what we're trying to do is we will use Telnet. It is name. Okay. IP access extended permit. Okay. What we are trying to do? From where we are trying to block Telnet. Okay. Say a router 1 here. A router 1 is ISP's router, and router 3 is your organization's router. So for security reason, you want to block Telnet from router 1. Is one approach. In that case, you will configure outbound Telnet blocking. Okay. It is one approach. Okay. You will just block Telnet or SSH service block outbound. Okay. Or other approach would be here. Okay. Here we in this lab I just planned that we will use inbound from router 1. Inbound block. Why inbound block? Because for some reason we want that everybody should everybody connected to this router should not be able to telnet this router. Okay. Okay, we are just testing it. But you can utilize it based on your security strategy. Where you are trying to block. For example, this router is another department. Okay. Say you are connected, your IT department's office is connected to this router, but this router is connected to say some other department. Okay, so you want to ensure that Telnet should not work in this router. Okay, so from this router, you are to block Telnet inbound in that case. Okay, so we will create extended. So extended and named, extended and named. Extended means you can block traffic based on service also. With a standard, you can just use source IP address. With extended, you can use source, destination IP address, source, what is source? Source IP, source, and destination IP, destination network, source network also. Okay, network means a wide range of IP addresses. Okay, and then we can also mention protocol, whether it is TCP or UDP, and then we mention the port. Okay, here Telnet 23 will be permitted or blocked. Okay, so okay. We'll create like this. We can show only one. You can do it yourself, but I am showing just with only one statement. Just deny. Okay. Say okay. Let me take command so that I don't make any mistake. Okay. Say we want to make so IP access list extended deny telnet. Okay, telnet. Its name is deny telnet. Deny telnet. So what will be the statement? We can add a remark like this. Okay, remark, just write remark, just in a space invert. It is deny telnet. Telnet from okay, deny telnet for simplicity. Okay, we'll deny this. Deny TCP post, not post actually. Okay, host also. 172. We're just talking about this. Host is 2 actually. Any means there is a difference in the syntax. Host, when you specify single IP, then you will just write host before IP address. And then any means to any any network, okay, any host or any network, then equal to service port 23 is mentioned. Okay, we will run this in router 1. Okay, we'll run. Okay, now we'll enforce this, but keep one thing in mind, that when we allow and disallow Telnet or SHS, the interface is actually quite different. It can be different. Look, the interface is actually like what we command is access class and Telnet access class, then access, then access class, not access group. Okay, and what is our name? Deny Telnet. Deny hyphen Telnet. Okay. Incomplete. Oh, incomplete. What is the syntax? Inbound. Okay. It should be inbound. Okay. Yes. Okay, inbound. Okay, and now if we try to Telnet anywhere, it will be blocked. 172.168.1.1. From router 1 to maybe. No, sorry. It's working. How?
Oh, it should be outbound.
Yes, it should be outbound. Okay, right. You are right. Control F6. Okay, it should be outbound, right? Because we are blocking from inside. Okay, look, change your command. Okay, at first, oh no, I have to line interface is 0, 4. Okay, just remember when we use traffic about different traffic or even service, including Telnet, SSS also can be blocked through interface. But this is another approach using this. Okay, using this, and then we will access. Okay, access, not access.
Line
class.
B2 I saw.
Oh, line BTO. That is mistake. Line BTO. Line BTO 0, 4. Then we will mention access. Then automatically, if you ACC, then access class will automatically come. Then deny. It's case sensitive, of course. Telnet outbound. Okay. Out. Okay. Now, if we try to see Telnet 172.1.6.1. Okay. It should not work. What's wrong?
So can we verify whether if the access list is completable?
Yeah. Access list. Access list and deny. Okay. Oh. Our statement is not correct. Source destination. No, it should be okay. Denied source host means this router, and then to destination. Okay. Okay, I will discuss it tomorrow next session. Today we have no more time. We have okay. When you practice yourself, just try to follow this setup. Okay, at first. But what I tried to show you with this in a simplified and quite different approach. Okay, somehow there is some mistake. Okay, I will look into this and discuss tomorrow. Okay, we have a class tomorrow, and then we have also class on Friday. Okay. I'm just sharing 4 labs and okay. At first, I'm giving you this slide. You go through this slide for different syntax. Okay, you will learn and try to complete all the 4 labs. Okay. Somehow there is some syntax error or some mistake. Okay, we got it. I'm sharing with you. So it should be everybody should come from computer 7. Okay, you are getting slide. Okay, then I am sending all the labs. Okay, labs I am giving you and what format, no problem. Okay, just download all this. Lab 1. Oh, sorry, it is why it is changing. Everyone to just individual. Are you getting all these labs?
Yes.
Yeah. Okay. Yeah. If you complete all the 4 labs, your concept first one is error. How many files you received?
4 files, 3 labs, 1 PDF.
Oh, sorry. One file is. How many labs did you get?
3 labs.
Sir, you send one file, both of them the same. That is lab configuration and applying for MI.
Yeah, but one lab is making, but the file is not going somehow. Okay, let me see another lab. Why is it not going? Okay, it is maybe it is difficult one.
The last one restricting is not yet uploaded.
Yeah, one is not transferring some reason. Okay. Where is what? Okay, so this is another one. Okay. Okay, it is, but one file is okay, making trouble. Let me make it PDF, then try. Save it, PDF. Okay, PDF converted now. Hopefully, it will be transferred. Okay, everyone. Restricting. Okay. PDF inbound telnet. Restricting inbound telnet transfer. Okay. Did you got four labs and one slide file?
Yes, sir.
Okay. Just practice all the four labs, and we'll discuss tomorrow the pending part. Okay. Okay. Let's close. If you have any questions, okay.
Yes, sir.
Yes.
So could you verify the commands for the previous lab, because the lab of I think of Monday I try using some of the command, but it is saying on recognize command,
Okay.
like the netbios command, and also some of the no IP I try, but my packet tracer is refusing, is saying on recognize command.
Which command was problem?
Yeah, I tried to use the netbios command.
Well, not every command is used in packet tracer. Some are using on real life devices. So the command has
Yes, that is yes, that is an issue. Some commands may not work in packet tracer. The packet tracer has some limitations. It's true, but today, which command I tried, it should work. It is very basic, but some advanced commands not working. I know.
Okay.
Okay, I will discuss tomorrow. Okay, morning. Okay. Okay.
So, and also it will be more better and clearful for us to really understand, like when you start the command, before going to the access list, you need to verify the telnet. If the telnet is really working without any problem, then you can try to give the access list command, and everything will be well understood.
Okay, today we will finish here. Okay, tomorrow we will discuss.